Hello everyone, my name is B. Pavan and my roll number is 20955A0411 and I belongs to ECE third year B section, and my presentation is belongs to the subject digital signal processing, and the topic of digital signal processing is the mystery curve, a signal processing point of view. So my AIT Tech Talk topic is the mystery curve, a signal processing point of view. So the mentor, the faculty that belongs to digital signal processing is Dr. V. Padmanabha Reddy sir, and my presentation is about the mystery curve according to the signal processing point of view. So first let us understand what is meant by the mystery curve. The mystery curve is a linear combination of harmonic signals called mystery curves. So it can be defined simply as a linear combination of harmonic signals. Harmonic signals is nothing but repeating signals, that is like a periodic signals. It is a linear combination of periodic signals called as mystery curves. Based on polar coordinate systems and low pass filtering approaches, the patterns of the curves can be designed by locally curve tracing instead of trial and error, including not only two-dimensional but also three-dimensional 3D modeling. So the mystery curve can be drawn by depending on polar coordinate systems and the low pass filtering approaches. So by using these two different approaches, it depends on these two types of systems. One is polar coordinate system and the other one is low pass filter approach. So based on this, the mystery curve can be defined. So the mystery curve, the pattern of the so these curves can be designed, that is the curve, the patterns of the curves can be designed by simply locally curve tracing instead of trial and error. So instead of going for trial and error method, the curve patterns can be designed by simply locally curve tracing. These can be these type of curves can be designed not only in two-dimensional view but also in the modeling of three-dimensional, that is in three-dimensional modeling. So here we can understand what is meant by mystery curve. It is a combination of harmonic signals. Simply, it is a linear combination of harmonic signals, so it can be called as mystery curve. So in this mystery curve, generally we go for the trial and error approach in order to design a curve, in order to design a system based on these mystery curves. So whereas in this mystery curve we go for locally tracing approach instead of trial and error in order to design the pattern of the curve. So this includes, that is, this can be included using trial and not only two-dimensional but also it can be designed in three-dimensional modeling. So we already seen that mystery curves can be designed or generated by using different approaches. So here we can see the one of the approach. So there are many approaches for generating the mystery curve. So I have explained here one of the approach for the generation of more mystery curve. One of the approach of generation is by using Fourier series analysis. So in that approaches, the one of the approach is the Fourier series approach. So in this approach, a n-fold symmetric curve must satisfy the following equation. So in this Fourier series analysis, an n-fold symmetric curve should satisfy the given equation such that the mystery curve can be generated. So the equation is e power j 2 pi k by n into Ct is equal to C of t plus 2 pi by n. So here exponential of j 2 pi k by n into C of t is equal to C of t plus 2 pi by n, whereas pi is a constant and k and n are belongs to integers, and t is C of t is varies with respect to time. Here the time period is increased of 2 pi by n, that is the signal gets delayed. So if this equation is satisfied, then the mystery curves can be generated by using this type of approach. So here the n and k are belongs to co-primes. So here we can see the equation in this the exponential part e power j 2 pi k by n. So the k and n are defined as integers. So n and k are co-primes. So what is meant by co-primes? That is simply the physical meaning of this equation is that the time delay is equal to some rotation of the past. So simply we can say this equation the time delay is equal to some rotation of the past, that is some of the past rotation is being added to the equation in order to generate the mystery curve. So when the constant integers, that is k and n are not co-prime, then the GCD of k comma n is equal to d, that is greater than 1, then n dimensional n-fold symmetric curve will be generated instead. So if they are not prime, here we have seen that in this equation n and k are co-primes. So when the n and k integers are not co-primes, then the GCD of k comma n must be equal to some constant that is greater than 1, such that the n-fold symmetric curve will be generated. To derive the constraints of COT, we expand it by Fourier series. So here the C of t is expanded by using Fourier series in order to derive the constraints of C of t. Here we can see the some of the images that represent the mystery curves. See, there are different types of curves in different shapes. They are in different motion, and they are in not only 2D but also they are in 3-dimensional. See, here we can see the patterns are really quite different. In all the images, the pattern are quite different, in which the one image pattern is not even comparable to the other. So in this way, there are different types of mystery curves. Based on different approaches, the mystery curves can be generated, and here I have been explained one of the approach of generation of mystery curves, that is Fourier series analysis. So in that there will be an equation which by which it satisfies the equation, then the curves can be generated by using mystery curves. So in this way we can explain this as mystery curves generation. Thank you.